to its limits. This is a black hole, a region
Imagine a place in space where gravity is so strong that nothing, not even light, can escape. This is a realm where the usual laws of physics seem to break down, and the very fabric of reality is stretched to its limits. This is a black hole, a region of space-time where matter has been squeezed into an infinitely small point, known as a singularity. The gravitational pull here is so intense that it warps space-time itself, creating a point of no return called the event horizon. Black holes are among the most fascinating and enigmatic objects in the universe. They captivate scientists and the public alike, offering a glimpse into the most extreme conditions imaginable. They challenge our understanding of physics and offer a glimpse into the extreme limits of gravity. The intense gravitational forces around black holes can tear apart stars and even bend light, creating spectacular phenomena like gravitational lensing. Black holes are not empty spaces, as the name might suggest. Instead, they are regions of incredibly dense matter, where the mass of millions or even billions of suns is packed into a tiny volume. This matter is packed so tightly that it creates a gravitational pull so strong that it warps the fabric of space-time itself. The closer you get to a black hole, the more extreme these effects become. This warping of space-time can lead to some mind-bending phenomena, such as time dilation, where time itself seems to slow down near the event horizon. The study of black holes allows us to test the boundaries of our knowledge about the universe. By observing these cosmic giants, scientists can gain insights into the fundamental laws that govern everything from the smallest particles to the largest galaxies. They push the limits of Einstein's theory of general relativity, which describes gravity as the curvature of space-time. Black holes serve as natural laboratories for testing these theories under the most extreme conditions, helping us to understand the universe in ways we never thought possible.
Stars are giant balls of gas, primarily hydrogen and helium.
Black holes are formed when massive stars die. These cosmic giants undergo a dramatic and violent end, leading to one of the most fascinating phenomena in the universe. Stars are giant balls of gas, primarily hydrogen and helium, held together by their own gravity. These celestial bodies are the powerhouses of the universe, providing light and heat to surrounding planets. The intense pressure and heat at the core of a star cause hydrogen atoms to fuse together, forming helium and releasing enormous amounts of energy. This fusion process is the engine that drives a star's brilliance and longevity. This process, called nuclear fusion, is what makes stars shine. The energy produced radiates outward, giving stars their characteristic glow that can be seen across vast distances in space. However, even stars have a lifespan. Over millions or even billions of years, they go through various stages of evolution, from their birth in stellar nurseries to their eventual demise. When a star much more massive than our Sun runs out of fuel, it can no longer support itself against its own gravity. The balance between the outward pressure from nuclear fusion and the inward pull of gravity is disrupted. The core collapses inward, and the outer layers of the star are ejected into space in a spectacular explosion called a supernova. This explosion is so bright that it can outshine entire galaxies for a short period. If the core of the collapsing star is massive enough, the gravitational pull becomes so strong that it overcomes all other forces, including the outward pressure that normally keeps matter from collapsing completely. This leads to the formation of a black hole. The core continues to collapse until it becomes infinitely dense, forming a singularity, the heart of a black hole. This singularity is a point where the laws of physics as we know them break down, and it possesses an immense gravitational pull that nothing, not even light, can escape. Surrounding the singularity is the event horizon, the boundary beyond which nothing can return. Once something crosses this threshold, it is inevitably pulled into the black hole, adding to its mass and gravitational influence. As a black hole consumes matter, it often forms an accretion disk of gas and dust spiraling into it. This disk can emit intense radiation, making black holes some of the most energetic objects in the universe. Black holes play a crucial role in the dynamics of galaxies, influencing the formation of stars and the evolution of cosmic structures. They are not just the end of a star's life, but also a key component in the ongoing story of the universe.
Not even light. Think of the event horizon like a waterfall.
Surrounding a black hole is an invisible boundary called the event horizon. This is the point of no return. Once something crosses the event horizon, it can never escape the black hole's gravitational pull, not even light. Think of the event horizon like a waterfall. Once you go over the edge, you can't swim back up. Similarly, anything that crosses the event horizon of a black hole is destined to fall into the singularity at the center. The event horizon is not a physical barrier. It's simply a region in space-time where gravity is so strong that all paths lead inward. Even if you were to shine a beam of light directly away from the black hole once you were inside the event horizon, the light would still be bent back towards the singularity.
These forces arise because the gravitational pull is much stronger on your feet.
What would happen if you were to fall into a black hole? Let's just say it wouldn't be a pleasant experience. As you approach the black hole, you would experience extreme tidal forces. These forces arise because the gravitational pull is much stronger on your feet than on your head, assuming you're falling feet first. This difference in gravitational pull would stretch you out like spaghetti, a process aptly named spaghettification. As you fell further, the spaghettification process would continue, stretching you thinner and thinner until you were eventually ripped apart into your fundamental atomic components. But what happens at the singularity itself remains one of the biggest mysteries in physics. Our current understanding of physics breaks down at the singularity. We don't know what happens to matter once it reaches this point of infinite density.
However, we can still detect them indirectly by observing their effects.
Section 5. Peering into the darkness. Unraveling the mysteries of black holes. Black holes are invisible to telescopes that detect X-rays, light, or other forms of electromagnetic radiation. However, we can still detect them indirectly by observing their effects on their surroundings. For example, when matter falls into a black hole, it forms a swirling disk of superheated gas called an accretion disk. This disk can emit intense radiation that we can detect from Earth. Additionally, the immense gravity of a black hole can distort the light from objects behind it, creating a phenomenon called gravitational lensing. Scientists have also detected ripples in space-time, known as gravitational waves, that are produced when black holes collide. These observations provide further evidence for the existence of black holes and offer a new way to study these enigmatic objects.
Of black holes and their mysterious nature. One of the most notable
Section 6. Echoes from the Abyss. Recent discoveries and breakthroughs. In recent years, there have been several groundbreaking discoveries that have significantly advanced our understanding of black holes and their mysterious nature. One of the most notable achievements was the first ever image of a black hole's shadow, captured in 2019 by the Event Horizon Telescope. This monumental image was a result of a global collaboration of scientists and observatories, working together to achieve what was once thought impossible. This image provided direct visual evidence for the existence of black holes and confirmed many of the predictions of Einstein's theory of general relativity. The bright ring surrounding the shadow, known as the event horizon, offered a glimpse into the intense gravitational forces at play. Another significant discovery was the detection of gravitational waves from the merger of two black holes. This groundbreaking observation was made possible by the advanced capabilities of gravitational wave detectors like LIGO and Virgo. This observation not only confirmed the existence of gravitational waves, as predicted by Einstein's theory, but also provided the first direct evidence that black holes can merge. The ripples in space-time caused by these cataclysmic events have opened a new window into the universe, allowing scientists to study cosmic phenomena in unprecedented detail. These discoveries have opened up new avenues of research and deepened our understanding of the role that black holes play in the evolution of the universe. From their formation to their impact on surrounding matter and energy, black holes continue to be a focal point of scientific inquiry, driving innovation and expanding the frontiers of human knowledge.
Mysteries in physics and cosmology. For example, black holes are thought
Section
to play a
7.
crucial role
The
in
universe's
formation
grand
and
puzzle,
evolution
black
of
holes and the
galaxies.
big questions.
Most galaxies,
Black holes are not just fascinating objects in their own right, they also hold clues to some of the biggest mysteries in physics and cosmology. For example, black holes are thought to play a crucial role in the formation and evolution of galaxies. Most galaxies, including our own Milky Way, are believed to harbor supermassive black holes at their centers. These behemoths, with masses millions or even billions of times greater than our our sun, exert a powerful gravitational influence on their surroundings, shaping the structure and evolution of their host galaxies. The study of black holes also has implications for our understanding of the fundamental laws of physics. As mentioned earlier, the singularity at the heart of a black hole represents a breakdown of our current understanding of physics.
By studying these enigmatic objects, we gain a deeper understanding
Section
of the
8.
universe and
Keep
our
looking
place
up.
within it.
The never-ending
The quest
quest
to
for
unravel
knowledge.
the secrets of black
The universe
holes
is full of
ongoing.
wonders,
With
and
each
black
new
holes are
discovery,
just one
we inch
example of the
closer
many
to
mysteries that
comprehending
await
the
our
true nature of
exploration.
these cosmic
By
abysses
studying
and the
these
fundamental
enigmatic
laws that
objects,
govern our
we gain a
universe.
deeper understanding
next
of the
time you look
universe
up at
and
the
our
night
place
sky,
within
remember
it.
the
The
incredible
quest to
power and
unravel the
mystery
secrets of
black
black holes is ongoing.
Never stop
With each
asking
new
questions,
discovery, we
for it
inch
is
closer
through
to
our
comprehending the
curiosity
true
and thirst
nature
for
of these
knowledge
cosmic
that we
abysses
continue to
and the
unravel
fundamental
the
laws
wonders
that
of
govern
the
our
cosmos.
universe. So, the next time you look up at the night sky, remember the